Last week we began looking at the flat Earth documentary Scamtarctica, produced by the channel Spacebusters. Having dealt with the first part, we swiftly move on, so this is Debunking a Flat Earth Documentary Part 2. Hello all and welcome along to another episode of Flat Earth Friday with me, Simon Dan. Thank you very much for joining me. Right, on with today's video and part 2 of debunking the flat Earth documentary Scamtarctica. We join Spacebusters just as they're about to talk about the data. This should be good.
Suspiciously, there are only two major online sources to consult when checking the dates the alleged 24-hour sun periods stop and start at these bases, length of days on the days just before and after, sunrise and sunset times on those days, and solar noontime for these bases on Antarctica. They are timeanddate.com and dateandtime.info.
Straight away, this is incorrect. There is the Australia Antarctic Programme website, the NOAA website as well. That's another two right off the bat.
This in itself is strange and a very easy way to control and fudge information. And again, there may be other software, apps, etc. So the community now needs to double check my data and check other sources against this. I was able to find a third site, sunrise.maplogs.com, that had stats on 5 of the 46 major bases of interest for another comparison.
So you claim there were only 2 and then you come up with another one yourself. Is this guy for real?
And Jaren, you might want to hold off on that NASA t-shirt just yet. You're about to be space busted.
Hey, that's me. I'm famous.
Let's start with the accuracy and reliability of this globe model's ability to at least predict what day the alleged 24-hour sun period starts and finishes for each base. Here's McMurdo Station, allegedly located on the inner 77.5 south latitude ring. According to dateandtime.info, the 24-hour sun period starts October 22nd, yet according to sunrise.maplogs.com, it doesn't start until October 23rd, a whole day later. And according to timeanddate.com, it doesn't start until 2 days later on October 24th.
Okay, first off, you expect us to listen to you about all this information, yet you can't even read latitudinal coordinates correctly. McMurdo Station is 77 degrees and 50 minutes. That's 77.8 degrees, not 77.5, as the minute units is out of 60, of course. Secondly, the NOAA website says October the 23rd, the same as sunrise.maplogs. But this is not the big point that you think it is. Each site may define 24-hour sunlight differently. For example, some count the first day as the day that the sun doesn't set at all. Others might wait until even the upper edge of the sun remains above the horizon for 24 hours, rather than the whole disk. They might also use different rounding conventions and slight variation in station coordinates or elevation assumptions. All can lead to a one-day shift, especially when you're that close to the threshold. If your entire argument hinges on this, on whether the sun stays fully above the horizon on October the 22nd or the 24th, but all 3 sources agree that it happens around then, you've accidentally shown how robust and predictive the globe model is.
This is an error rate of 2 whole days, and none of the 3 even agree. And yet, when you look at the dates they allege the 24-hour sun ends and periods of dusk or sunrise-sunset start, suddenly date and time and date both agree it's February 20th. Yet they were off by 2 days from each other when it starts, and sunrise.maplogs claims the 24-hour sun ends a day before that, on February 19th.
I think our friend is missing the entire point here, and that is that all these websites agree that the sun doesn't set for months, which would be utterly impossible on any flat Earth model. It's not just unproven, it's geometrically impossible, as the final experiment showed.
So while for McMurdo Station, Date and time are clearly showing 24-hour sun starting October 22nd, still there the 23rd and 24th, so there are no sunrise sunset stats or day lengths to track and report. Simultaneously, timeanddate.com are giving a very specific sunrise and sunset time on the 22nd, where date and time just said it was already a 24-hour sun. Even an incredibly specific day length time of 22 hours, 57 minutes, and 38 seconds down to the second, and have a partial 1 hour and 2 minute period of nighttime from 12:40 a.m. until 1:42 a.m. on the 23rd, when again time and date said it had already been a 24-hour sun that day and the whole day before on the 22nd.
Now, I thought I would check to see how this looked on the piece of software Stellarium. And lo and behold, at 12:40 a.m, when time and date says the sun sets, this is how it looked. Now, you may notice in the bottom right corner the time is not correct. I had to use UK time as it was not adjusted for that. But you can clearly see that a small portion of the sun is still just above the horizon. This means that there will clearly be differences across different platforms. Fully expected.
And sunrise.maplogs is also showing very specific sunrise, sunset, and day length times for October 22nd, where date and time claim it was already a 24-hour sun. And by the way, sunrise.maplog's sunrise, sunset times for the 22nd are off by 13 to 18 minutes from time and date, despite both giving details of their alleged certainty down to the second. How can you both be certain to the second of your accuracy and be off from each other so wildly, up to 1 or 2 whole days?
Just because a website claims to know the time down to the second, that does not mean it knows the cosmic truth down to the second. It's just reporting data in a precise format, based on its internal model and assumptions. Now, if one model includes refraction, observer altitude, and the sun's upper limb, and another does not, then you are going to get differences in minutes, especially in extreme locations like Antarctica, where we've already seen the sun skims the horizon at very shallow angles. The models aren't broken, they're just slightly different versions of the same globe-based system. And the fact that you're arguing over minutes is proof of how well they work, not how badly.
McMurdo Station is only 1 kilometer or just over a half a mile long. Imagine it's October 25th, and you have to interview 3 different people sitting a few blocks down from each other in McMurdo Station. The pink one claims they saw the sun go down for brief dusk or dark October 22nd, and then saw 2 days of the sun in the sky for 24 hours on the 23rd and 24th. But the blue one says, no, I was also here. I saw the sun go down for dusk or dark on both the 22nd and 23rd, and then yesterday on the 24th was the first day the sun never went down. And the green one says, no, you're both wrong. I was also here, and the sun never went down on the 22nd, 23rd, or 24th. The 21st was the last day I saw a brief period of dusk or dark.
We're talking about solar geometry here, not personal opinion. What this part accidentally does is highlight something. How small differences in perception, position and definition can explain apparent contradictions. Are you trying to argue against yourself here?
At least 2 of them have to be lying. They can't all disagree and all be correct. But how do you know who's lying? They could all 3 be lying for all you know. Especially when you ask them when they saw the alleged 24-hour sun period end and brief dusk or darkness return. And suddenly, the blue and green both agree on the same day, February 20th, when they disagreed by 2 days in October, and the pink claims, no, I saw a period of dusk or darkness the day before on the 19th.
Why are you talking about lying? This isn't a Hercule Poirot story. Besides, all this is that when the sun hugs the horizon, a few minutes or meters or degrees makes a difference. That's not contradiction, it's a globe in action.
Would you base an entire belief system on their inconsistent testimony, saying, close enough, like Jaron? Or would you smell a rat and investigate all of the bases? To save this film from being 8 hours long, I've spent 2 weeks putting it all into spreadsheets rather than showing you 400 screenshot comparisons. But again, go double check my work. Don't be lazy and blindly trust my spreadsheets like Jaron trusts Globe software. Good research is verifiable.
I have no doubt in your research. In fact, I get why you wanted to be so thorough. I just think you're misinterpreting your results, as I've already explained.
Be aware that timeanddate.com and dateandtime.info are both using a same standard time zone for all 22 bases out of the 46 that they both have information on. But sunrise.maplogs.com is using 5 different time zones, so you have to subtract 5 hours for Casey, 7 hours for Vostok, 6 hours for Davis, and 3 hours for Dumont d'Urville to get them to the same zone as the others. And no, that is not proof of this. That works the same if the bases are scattered around the edge of the ice wall in reality. Even better, as you'll see.
Oh, will we now? Will we see it work even better? Can't wait for this.
Back to McMurdo, we've already seen that they can't agree what day the alleged 24-hour sun starts and ends each year. The last day all three agree there wasn't a 24-hour sun was October 21st. So I checked the length of day on that day to see if they at least agree on that, since they're all sitting within a half mile of each other, and then the sunrise and sunset times to see if they at least agree on that. Sunrise.maplogs doesn't track the solar noon, so those are on the other charts we will examine soon.
Again, this isn't suspicious, this is normal, especially when comparing tools that use different coordinate inputs for McMurdo Station, may or may not adjust for elevation, terrain obstruction or refraction, and possibly round sunrise or sunset times to the nearest minute or second.
Sunrise.maplogs and timeanddate.com seem to agree close enough for even me within 14 exact seconds on the length of day October 21st. But dateandtime.info says the day was 27 minutes longer. I don't know if that's what Jaron means by if you map the Earth on a sphere, then every sunrise and sunset time and angle is predicted and accounted for every single location there is.
Let's be clear here, this isn't a problem with the globe. It's a problem for dateandtime.info. That particular website is known for being less precise, especially when it comes to polar daylight modelling. It's likely rounding aggressively or using a simpler algorithm that doesn't actually account for things we've already talked about, like refraction or observer's elevation or the definition of what a sunrise and sunset actually is. I looked at it myself and it does look pretty dodgy to me. If 2 independent tools agree within 14 seconds and one outlier disagrees by 27 minutes, the rational conclusion is that the outlier is off, not that the entire model is broken.
McMurdo Station is on the 77.5 south latitude.
Again, got that wrong, you can't read coordinates. Not surprising for a flurf, but there we go.
On the globe model, the equator at 0 latitude has to be spinning at 1,040 miles per hour to make a 24-hour day, because it is said its circumference is 24,901 miles around there. So down where McMurdo is at 77.5 south latitude, the circumference around is smaller, so it must be spinning slower to make the exact same rotation as the equator in 24 hours. Simple enough.
Except when we look at rotational speed, 15 degrees per hour, we can see that it's exactly the same.
That rotational speed at McMurdo would be just over 225 miles per hour, or 3.75 miles per minute. If the day were 27 minutes longer, that's over a 101-mile visible sun distance for a third measuring station located within a half mile of the other two, And this gets more ridiculous as these day-length discrepancies reach over an hour to 2 hours and 20 minutes from each other, as you'll see.
Well, the issue is obviously dateandtime.info then, isn't it? So let's have a look at what dateandtime.info themselves say about how the website works. They explain that it was developed to provide correct and relevant information about time zones and time differences. That's fair. It's primarily a world clock and time zone tool, not a dedicated solar calculator. Then they list the technologies used: CentOS, Apache, MySQL, PHP, jQuery, all perfectly normal web stack stuff. But here's what is not listed. No mention of solar position algorithms. No reference to astronomical models. No evidence for accounting for anything like Earth's axial tilt, solar declination, observer altitude, or atmospheric refraction. Instead, the only scientific source they mention is the TZ database. That is a time zones database. Now that's great for telling what time it is in Toronto or Tokyo, but it doesn't calculate the position of the sun in the sky. In other words, they're not solar modelers. They're time zone calculators. Now let's see what timeanddate.com use. They use the VSOP87 planetary theory, refraction correction algorithms, precise geolocation and elevation handling. That's why timeanddate.com is so trusted by scientists, teachers, software developers, and why it agrees with NASA, NOAA and Stellarium. Within seconds as well. Even in Antarctica. So the issue here is clearly your choice of dateandtime.info. And at the moment you're basing your entire argument off of it. Dear, oh dear, oh dear, oh dear. Well, I think that seems like a good place to pause here and finish episode 2 of Debunking Scamtarctica. Let me know in the comments below what you thought of this part. As I say, we're all done and dusted for another one. Thanks so much for watching today. As ever, it's appreciated. If you enjoyed it, please do consider subscribing to the channel and giving the channel a big thumbs up too. Thank you very much. I've been Simon Dan. Have yourselves a great day, and I'll see you tomorrow for a Saturday session where we'll be looking at ChatGPT mistakes, and some of them are quite funny. See you then.